Alright, so in this problem here, you have a velocity time graph where the velocity is starting at some value, increasing at a constant rate up along this portion here, and then eventually flattening out to a flat line there before it decreases back down to zero velocity down here and then popping up a little bit at the end. So what I'm going to do is make an acceleration time graph and a position time graph in different colors here. So let's do the acceleration time graph first because it is the easier one to do. Let's pick green. Alright, assuming this is 0 down here. So remember that when you want to find the acceleration time graph from a velocity time graph, you have to look at the slope. So right here we have constant slope that is a straight line. So from this point to that point we have positive slope. So it's going to give us a positive flat line in the acceleration direction. The slope then goes from being positive around here to being 0 right there. So we need to take our line and take it down to the 0 axis. We then go from 0 here to a straight line negative slope down there. So we need to take our green line and continue it on down. And if you look at your graph, once you reach this time interval right here, it kind of curves up a little bit. So this has 0 velocity. So if you have 0 velocity, you'll have 0 acceleration. So we need to pull it back up there. It's going to stay here for just a little bit. And then our slope begins to get positive again. So we're going to pop up here and leave it positive there. Alright, so that's the acceleration time graph. The position time graph is much more difficult to create. So I'm going to make this in purple. I'm also going to erase my acceleration time graph for you. Let me see if I can make it without messing everything up too much. Alright, you can still see the velocity time graph that we started with here. Alright, so we're going to do our position time graph in purple. Now, we don't know where exactly it's beginning at, so I'm just going to assume it begins at 0. And remember that the position of the slope of a position time graph gives you your values for your velocity time graph. So initially, my velocity time graph is a straight line that's going in the positive direction, the positive upward direction, which means our slope must start out positive and get greater and greater. So we're going to curve just like that. And that's what you had earlier, Evelyn. Now, we go from this point to being flat here. Now, if you remember, a flat line on a velocity time graph indicates that there's no changing velocity, so it should be a straight line on our position time graph. So we just go straight a little bit. You won't be able to see it very good on this graph because we have so many different curves going on. Then we transition to this area over here where our velocity is decreasing and approaching 0. So you should know that if you have 0 velocity, then it's going to be a straight flat line on your position time graph. So we curve up, and then we have to curve over till where we reach 0 at. So it's kind of like a little S shape of some sorts. Then on this area here where we have 0 velocity means we're not moving. So we're going to just stay at this position time graph, which is going to be flat for a little while. And then the last little bit where it pops up here again, our velocity is getting bigger and bigger, so that means our slope must be getting bigger and bigger, so we're going to do a little upward curve just like that. So that's what your position time graph looks like.